Hi, welcome to Viterbi Bros. In today's video, we're gonna go over some exercise of runtime analysis. So let's start with the first problems. In these problems, you're gonna find a user with ID equal to 3FEEAA inside an unsorted list of n unique IDs number. So this is gonna be the list that we're talking about in the problems, which has n items. And the person that we're looking for, which is 3FEEAA, actually at the end of the list. Now, the most obvious approach to solve this problem is to scanning each item until you see the person that you're looking for. For example, you're gonna start at the beginning. You're gonna asking this person, "Are you the one I'm looking for? Are you the one I'm looking for? Are you the one I'm looking for?" Until you reach at the end and you find your 3FEEAA person. Now, let's discuss the best case of this problem. Let's assume the person that you're looking for, which is 3FEEAA, standing in the front of the list. So when you're scanning, this person always staying on the front. That's why it's gonna stop immediately when it see this guy. So it doesn't have to scan the rest of this list. Therefore, the best case is gonna be omega 1. But since we're engineering, we only care about the worst case. So the worst case for this problem is when the person on the back of the list, which is right here. So since the person on the back of the list and the list has like n items, the worst case runtime gonna be ON, which is like you using the for loop to scanning an array or a list or the vector to reaching the last item. So now let's start with the second problem, which is more complicated than the first one. In this problem, you're gonna find the pair of city that has the shortest distance in the map. So this is the map that we provided to you, and each node in the map gonna represent the city. You have Metropolis, Westminster, LA, Boston, New York, and Gotham. So before finding which pair that give the shortest distance, you have to generate all the possible pair of city that this map can generate. And after that, you're gonna compare them against each other in order to figuring out which pair gonna provide the shortest distance. Let's try to generate a few possible pair. Let's say Metropolis and LA, one pair. This one's one pair. Westminster, New York, one pair. One pair right here. And LA, Boston is one pair. Westminster, Boston, one pair. And you can try it on your own. So now let's discuss the algorithms in more formal way. So the first step, which we will discuss, find all the possible unique pairs of the city on a given map and store them in a list. So let's assume this is going to be the list that we mentioned in the first step. First element going to be the first pair, which is Metropolis and LA, and this number here represents the distance between them. Second element going to be Boston, LA, which is 2000, Westminster, New York, 3000, and Gotham, New York, 9000. And this symbol right here indicate like other possible pairs that we don't have enough space to write it down in the slide. So now the question is, what's the runtime of this first step? Because we try to generate all the possible unique pairs of city. So that's why the program gonna terminate when it reach the last item or the last pair. So let's say the map can generate the total of X possible pairs of city. Then the last item gonna be the X. So therefore, the program gonna terminate when it's reaching the X items, which is Gotham and New York in this image. Thus, the runtime equal to the number of possible unique pairs of city, and you can say it like equal to the length of the list. Now let's start with the second step of the algorithms, which is scanning through the list that we have created in the first step to find the pair with the shortest distance. So before scanning through the list, let's create a variable called min that's gonna keep track of which pair gonna give the shortest distance, and we're gonna start it up with a huge number, let's say 9 billion miles. Okay, so let's scanning. So we're gonna scan the first pair, gonna be Metropolis LA, and we're gonna compare the distance with the min we have right here. And since 1000 less than the min, which is 9 billion, we're gonna update the min with 1000. Let's scan to the next item, which is Boston LA, which is 2000 miles, and you compare with the min 2000 is not less than 1000, so you don't update the min. And you're scanning to the third one, Westminster, New York 3000 with a min, which is not less than, so you don't update the min, and until you're reaching at the end of the list. And because the length of the list equal to the number of possible unique pair of city, so that's why the runtime of scanning is also equal to the number of possible unique pair of city. After that, your total runtime gonna be the summation of this one and this one right here. So I'm gonna write 1 and 2, gonna be 1 plus 2. Okay, so on the next slide, I'm gonna show you how to find a possible unique pair of the city. So now we're gonna find the exact total number of unique possible pairs gonna be generated by the city. I'm gonna put a list of city over here, and we're trying to find how many unique way can you form a group of 2, because this is a pair. So you're gonna have like New York, Metropolis, Gotham, Westminster, LA, and Boston. So this reminds you of the combination formula from the probability course. And we choose combination because we want the unique pair. So since we have 6 cities and we try to create a group of 2, we're just using 6 C2. This means create a group of 2 from 6 items. Since we want more general way to solve this problems, let's call the total number of cities gonna be n. Therefore, it's gonna be n C2. So for n city, how many unique way can you create a group of 2 or a pair? So let's plug it in the formula. You're gonna have n factorial, 2 factorial, and n minus 2 factorial. And you can simplify the problems. That expanding the n factorial gonna be n minus 1, and 2 factorial gonna be 2, n minus 2 factorial. You cancel those 2 out. So your final solution gonna be n squared minus n over 2. So this gonna be the total number of possible pairs can be generated by the n cities provided by the maps. So in general, those steps right here gonna give you the list of all the possible unique pairs that written in the form of n squared minus n over 2. So now, since we proof of like all the possible pair of city gonna be n squared minus n over 2, so the runtime gonna be equal to this. And similarly, since scanning through the list also have a similar runtime, it's also equal to n squared minus n over 2. Now we add those two together, getting the fn function, and then simplify it to n squared minus n. And in the long run, when n goes to infinity, n squared gonna dominate the n. Therefore, your answer is gonna be on squared. Therefore, the runtime to find the pair of city that had a shorter distance gonna be n squared. So now let's go to the third problem, which is kind of similar to the second problem. In this problem, you're gonna find how many group of K's member can be formed from n people. So this is gonna be the list of n people right here, and this is gonna be the K group member. So this kind of remind you of the combination formula again. So you can see from n people, how many way can you generate the group of K members? So it's gonna be n people, C and K. So now n C K, let's simplify this. And for the n factorial, you can expand into n minus 1, n minus 2, dot, until n minus k plus 1, and n minus k factorial. Everything over k factorial, n minus k factorial. So those two terms gonna be crossing out. So you look at here. For n and n minus 1, there's gonna be 2 terms, right? So the highest degree you can get from the product of those two gonna be n squared. And similarly, from n until n minus k plus 1, they're gonna be k term. So the highest degree you can get from the product of those terms gonna be nk. Therefore, let's write that nk plus other term over k factorial. And since nk is a term with the highest degree, everything else lower than k gonna be ignored when n goes to infinity. So that's why the runtime of this problem gonna be onk, because as n goes to infinity, everything like nk minus 1, n2, and 1 gonna be ignored because nk appears to be larger